Alright, so I have the bell housing transmission all pulled apart here. I needed to check the OD of the front cover of the T5 Borg-Warner transmission here because I'm going to be using a hydraulic throwout bearing, as I explained. Not going to make the cable actuated or what would have been a Z-bar actuated mechanical clutch linkage work. We're switching over to hydraulic. One of the other things I need to do while I have this apart is fix this bell housing. Now this bell housing came bolted to the engine, and a GM bell housing is a GM bell housing for the most part, to the point where this bolt pattern works for the T5 transmission. So therefore it worked for what I was going to use it for. The only issue, it might be hard to see here, but you can definitely see these threads are a little compromised. About this one's a little worse. It takes about ½ inch to get down to some decent threads, and the rest of them about ¼ inch at least to get down to some decent threads. And this is pretty thick. The threads are. I mean, they're probably an inch and a quarter worth of threads there. So I could just leave it and get the proper length bolts here, which I'm going to do anyways, and just live with it having some garbage at the beginning of it. But what we're going to do instead is fix it the right way, and that involves helicoiling it. If you're not familiar with a helicoil, this is a helicoil. So our bolt our thread in the bell housing is ½ 13, so this is a ½ 13 bolt. All those threads, for the most part, are junk. So what we need to do is put in one of these rethreading inserts. So the inside thread is ½ 13. The outside thread is 5/8 11. So what we do is we take a 5/8 11 tap and we put new threads into the bell housing. We screw one of these helicoils in, then we break off the little tab. That little tab there meets up with the tool so that you can spin the insert in, and then you break that little tab off, and then you have a perfectly good hole with beautiful threads. And these things are strong enough to hold the transmission to an engine and things like that. This is not going to be a weak point in the system. And so we're going to do all 4 holes. These things come in metric, standard, pretty much all thread pitches, and they come in different lengths. So you just want to match the length to what you are going to be using it for. So I have 5 of them because they came 5 in this bag here. And I got the tap and the helicoils together, but I didn't get a drill bit with it. They do have kits that come with everything. And I didn't get a drill bit. If we look at a 5/8 11, we look at their chart here, a 5/8 11 uses a 21/32 drill bit. So come up here to the Williams hardware chart that I have here, and a 21/32, a decimal equivalent 0.6562. Now I don't have a 21/32. I do have a 5/8 though, which is 0.6250. So I'm going to drill it to 5/8, and that should be close enough, just 2 sizes away. That should be close enough to still be able to use this tap to tap the new threads in there. Now I'm going to get it all set up on my drill press, and I have this beautiful Fireball Tools table topper here, which is a precision made jig table with all the holes for fixturing and doing everything else. And so what I can do is lower this down. It's big enough that I can bolt the bell housing to it. I can get it nice and square with the drill and get it centered, and then I'll be able to drill a precise hole in the bell housing, and we'll do that for all 4 of the transmission threaded holes here, and then we'll go and we'll tap them out, and we'll put the new helicoils in, and then we'll be good as new. Okay, so I have the table perpendicular to the drill press. I have it at the right height, so I can switch out between bits here. What I have is a transfer punch that's the right size to fit tightly in the existing threads. So I can use this to make sure to center the bell housing up as I clamp it down to the fixture table. We know we're center. Now we can swap out the transfer punch for the 5/8 drill bit. I got the speed set on 340. We're gonna go nice and slow with this, and we'll use some cutting lubricant here. So I almost made a big mistake and used the wrong size drill. So now I have a 17/32 in here, which is the proper size drill for a 5/8 11 hole, which is what we have. So wish me luck. I don't have a lot of confidence in anything that's going on right now.
So I just used the original stage that came out of the disc. They set the backlash, which is how far the ring gear is pushed into the pinion. Put the caps in, a little grease on to make sure the teeth engagement looks right. And we will spin it. So the axle's going to seal it up. Cap it up. Boom. We don't have a spinning guy anymore. We've got a second, faster axle. It's all really nice and straight. And this is really a easy swap for the 31-point axle, which is what my Mustang is able to get. Alright, oh, look at that. This is really good. Alright, so that's it. Our 8.8 is pretty much together. You can put a portion on our rear end where you can save a bunch of money and build something like this yourself. We're ending this thing $390 for the rear itself. This is a $230-some calipers, pads, and rotors, power stop kit from Summit, and we spent about $600 splurge on that Detroit 2-track. and easily with a weekend job.
Yeah.
Can be done on jack stands as well.
So we're gonna add, oh, and the spare axle on the other side. But yeah, $1,300 or so, $1,400.
All right, it's time to get these helicoil inserts into our freshly tapped holes. You can see I have one of the helicoils in there already, nice and flush with the surface here. And so now I'll show you how to do it. So if you look at this, there's some spring in this. This needs to be compressed when you put it in. The tool that you use to put it in has this slot in it that matches up with the slot in the end of the helicoil, or the little tab there. That tab you wind up breaking off, right? This has a depth stop on it. I have a little washer on here because this is a little bit of a bigger helicoil, and the depth stop, it's kind of inaccurate because it's basically the same size as the depth stop. It can't fully go around and past the depth stop, but it doesn't interface with it good. So I just have a spring on here, and so what you do is you set your depth stop so when the spring is fully compressed, you still have a little bit of the slot left. So you have this little bit of compression that you can do. And so when you get the helicoil started, you need to fully compress this and keep it compressed the whole time that you screw it into the bore. So we'll do it on this one now. So you want to make sure we line it up with the slot here. And then we're going to put this in and get this fully compressed. And then we're going to start threading it in. Keeping it compressed the whole time. Keep going. And eventually it'll slip off of the tab. There it goes. And it's almost fully in there. But now that there's just a little bit sticking out, I can just take the washer off to make up the difference. And I screw that until the helicoil is flush. Now eventually you need to go back with the break off tool here and break off this tab that's sticking down. So you'll put this in there and you'll hammer that, and it's kind of hard to see with this, but there's this little divot right here, and that's the weak point in the helicoil, and so that will snap off. And then you can see the original bolt here goes in real nicely, and that'll hold all the foot-pounds of torque that you need to throw at it to connect the transmission to the bell housing. All right, so I'm over here and I'm getting the engine and transmission ready to go together for the final time, at least for now. And I mean, eventually it'll get taken apart to get painted next winter when everything gets torn down for actual paint and stuff like that. But I got the flywheel resurfaced by a local shop in town here. Got that reinstalled with the correct torque numbers and sequence. I have the brand new clutch and pressure plate installed. And here I have my T5 transmission. It's transmission that I picked up in a junkyard up in St. Cloud, Minnesota, and appears to be in really good condition. But the bare minimum that you want to do when you get something like this out of a junkyard is replace the input and output shaft seals. So I've gone ahead and done that. I got some Timken seals here. This is the tail shaft seal or the output seal on the back of the transmission, and this seal right here is the one for the front cover for the output shaft here. And so one of them is a 7412S and the other one is a 9613S. Those are for the T5 Borg Warner. And as you can see, I have a stud installed right here on the front cover because I am going to run this hydraulic throwout bearing. I was going to run the stock, not stock to the Aero sedan, but stock to the 72 Camaro, which is what this engine came out of. Clutch fork on the pivot ball and run a cable to actuate it. That was when I was going to be using the stock pedals, but I am no longer going to be using the stock pedals. I didn't have the pedals. I had the actual upper part, but not the linkages that go down to the stock master cylinder, which the master cylinder was this big underfloor unit that had 2 pivot points on it where those pedals mounted. I've been looking around for them, never found them on eBay. Had a bunch of flaky people on Instagram that never got back to me that said they had them. And I kind of want everything to be really nice and clean, like a nice clean firewall and everything. So I decided to convert to a hydraulic throwout bearing so that I can use a hanging pedal from like a modern car and use a universal hot rod style throttle pedal, and then I have a brake pedal that has a 90-degree bracket on it that holds the brake booster and master cylinder at 90 degrees to the pedal set so that the brake booster and master cylinder will actually be up underneath the dash instead of sticking through the firewall. So a real nice clean install. So I did some research and I wound up with this Howe Racing 82876 throwout bearing, and this throwout bearing is the right spec for the T5 transmission. So this has a -4 fluid inlet and then the bleeder screw here. Since this is obviously going to be installed on the transmission inside the bell housing, it's going to be really hard to bleed this as is. So I got a line kit from Howe as well that just puts 2 AN lines on here, 2 -4s, and those will come out of the bell housing where the clutch fork pivot did. They could also come out of the top here. I think we're going to route them out of here. But this is the right size so that it slips over the front cover of the T5, just like that. And then this rod here captures it between the 2 fittings so that the body of it can only spin that much. And so what it does is when you depress the clutch pedal, it forces fluid in here, and then this whole thing expands. So there doesn't need to be an external slave cylinder. This is the slave cylinder and the throwout bearing. So to get this to work with the setup I have to take a few measurements. So what I need to do is measure from the mounting surface of the transmission to these fingers, or bolt the bell housing on and measure from the face of the bell housing with my adapter plate to the fingers. Then I need to compare that to the measurement of the mounting surface of the transmission to the face of the throwout bearing, and I need to use that information to figure out how many shims I need to put behind the hydraulic throwout bearing to space it so that between these fingers on the clutch and the throwout bearing surface there's a 1/16 air gap. I need to do that because If there's no air gap, you're going to be putting pressure on these fingers, which is going to be taking pressure off of the clutch disc, and you'll burn up your clutch very quickly. In a really bad case, it would be putting so much pressure on there that the clutch disc wouldn't even engage. Now, the opposite of that is, say you have about 3/8 of an inch of an air gap here before this contacts the fingers on the clutch disc. Well, that means that your pedal is going to have that much more travel before you actually start disengaging the clutch. And further, this thing only has a certain amount of expansion to it before you'll actually puke out the throwout bearing from the slave cylinder and lose all your fluid, lose your pedal, and get stuck on the side of the road. So if this thing has a 1/16 inch air gap between the face of the throwout bearing and the fingers, then you'll have the right pedal travel to disengage the clutch properly and not expand the hydraulic throwout bearing to the point of failure. So that's what I'm going to do right now. I'm going to take those measurements. Then I will stack these shims behind it, however many I determine that I need. We'll put the bell housing on the transmission. Then we'll feed the lines through and into here. We'll take the bleeder off of here because this bleeder will be on the braided stainless line that comes out, and so we'll be able to bleed this outside of the bell housing, like I said, and we'll just route this along the firewall, kind of down the trans tunnel area to a point that we can get to it, but it's also inconspicuous and not an eyesore. Then we can put the whole engine and transmission together, and it'll be good to go so that I don't need to take it apart. Once I get the engine running, I'll be able to just put fluid in everything, start using it. So right now, like I said, we're gonna get this throwout bearing set, get the bell housing on the trans on the engine, and then we'll get the engine back in the car. Now, one of the things I'm doing right now in conjunction is, you see I have the driver's side motor mount that I made here. I'm actually gonna take this and cut this off and then shorten it. So I'll cut this about right here and then move this piece back and re-weld it. What that does is it takes this donut mount right here that used to be right here and in the way of the steering shaft and moves it inboard so that the steering shaft will be able to snake by the motor mount. So we're going to have to modify the chassis side and the engine side. And then once I do that, the motor will be in, will be mounted, and then I can do the steering column with the firewall flange bearing, and then from the steering column, build the steering shaft. Now that I have the headers and everything, I'll be able to finalize all this stuff here. I was waiting on the headers because I didn't want to make the steering shaft and then get the headers, which were on back order, and be like, oh crap, they occupy the same space. So now that I have all this stuff, we are cruising along here. So I'm gonna get going on the throwout bearing and get this motor mount modified, and we'll get this sucker back in. All right, I got everything set up here. So I got the bell housing bolted back to the engine, got the spacer plate on there because that's part of the dimensions for what I need to measure. I had some nice new hardware on the bell housing, and I actually used a torque wrench to torque that on. When in doubt, I always just love to use a torque wrench, make sure everything's nice and even. Of course, this is nowhere near as important as the flywheel and clutch disc, but here is the hydraulic throwout bearing, and I wound up needing 4 spacers behind it, and there's a little bit less than a 1/16 inch air gap. The instructions actually called for 0 gap between it, but no preload. And these are thick enough that if I put one more on, it would be touching it. So this is the perfect amount that I need on there. I have the Dash 4 stainless steel braided lines on there. So this longer one here is the bleeder. So I took the bleeder out of that line, put it in this little adapter fitting on the end here. This line is way longer than I need, and so I am going to shorten it. I don't know if I have the fitting I need to shorten it, but I'll order one, and I'll just take off the crimped fitting here, shorten it, and use a new AeroQuip fitting for a Dash 4 line to shorten this. But once this is in the vehicle, I'll be able to figure out exactly what length I need. And then this is the feed line here. It came with this 90 on it, which is going to be good because it is going to come up over here on the firewall. You can see that's the brake line that goes to the rear brakes. I have that nice bulkhead union with a washer with a rubber seal on both sides. And I'm going to be running all of the brake, clutch lines, everything through the firewall with that. So with that 90 on that fitting there, it will look real nice all up in a row, kind of hidden behind this here. And so nice clean installation. So now I'm going to get the transmission bolted to the bell housing.
That's not an hour.
That's not an hour.
Not an
but
hour.
it is.